Hi, I'm Professor Goins. In this video, I'm going to continue the discussion on geometric series. Part 3, we're going to look at functions as series. In particular, we're going to go series to a function, function to a series. We're going to go back and see how we can go back and forth. First and foremost, the basic formula for a geometric series is if I have the sum n equals 0 to infinity of a r to the n, this is equal to a over 1 minus r, remembering the restriction where I have to have the magnitude of r is less than 1. Okay. First thing I'm going to do is look at how do I change a series to a function. If I have a geometric series that has a variable in it, I'm going to treat this x over 2 as the value of r and just plug it into this formula right here. This would give me, so in this case, a is 1. This would give me 1 over 1 minus x over 2. And I can simplify that by multiplying top and bottom by 2. Distribute that through, that would give me 2 over 2 minus x. Therefore, this function right here and this geometric series are the same thing. If I want to evaluate this, I can just plug the x value into this function. This also would give me a way to graph a geometric series by if I can graph the corresponding function. One thing to keep in mind though is that if I give you this function here in isolation and I say what's the domain of that, the domain is everything except for 2, so minus infinity up to 2 and then 2 up to infinity. However, if this expression here is going to represent this expression here, the domain x over 2 would have to be between minus 1 and 1, therefore x would have to be between minus 2 to 2. This right here has a significant domain restriction, whereas this one does not. These functions only match on the domain restriction for the geometric series. Okay. For this one right here, again, it has the same form of a r to the n. Therefore, I can write this as 4 over 1 minus x minus 1 over 3. To simplify that, the quickest way to do it, I want to eliminate this denominator here, this 3. So I'll multiply top and bottom by 3. And that would give me 12 over 3 minus x minus 1, which would be 12 over, I'd have 3 minus x plus 1 would give me 4 minus x. Okay, so 12 over 4 minus x matches this function expression, matches this function here, again, only on the domain restriction for the geometric series. All right, so that's how I go from a series to a function, is by using, well, going from this side to this side. But we could equivalently go from this side to this side. Therefore, what I have to have, if I want to convert a function to a series, in particular a function to a geometric series, is I have to have a function that has this form here, a over 1 minus r, where the variable r, or the variable x, appears in this spot right here. This has to be a constant, this has to be a 1, and your r is like your x over 2 or your x minus 1 over 3. That's where your variable can be located. Let's take a look at these 3 examples here, and then we'll go through the specifics. Notice each one of these has that. I've got a constant, variable, constant, variable term, constant, variable term. Okay, let's go through how this would work then. Since I have that general form, I can see if there's any manipulations that I have to make in order to get it in that exact form. A can be any constant. This has to be a 1. This is where your variable has to appear. The only thing the change I have to make is this 3 has to be a 1. What I can do is I can factor a 3 out, giving me 4 over 3 times 1 minus x over 3. And then now my r is x over 3. And I've got a is 4, or you could think of that as 4/3, giving me the following infinite series. This infinite series is equivalent to this function. Again, only on the domain restriction for this infinite series though. This function is defined on all real numbers excluding 3. This one is defined only on an interval from -3 to 3. If you don't remember how to determine the interval of convergence, watch the part 2 video where we talk about the interval of convergence. All right, now let's go down to this one. A couple of different things I have to take a look at. One, this is not a 1, and this is a plus, not a minus. This one, both of those are pretty easy to manipulate though. What I'll do is I'm going to start by factoring out the 5, giving me 5 times 1 plus 2x over 5. And then in order to change this to a minus, I'll just put a minus here and a minus here. This would give you 3 over 5 times 1 minus negative 2x over 5. And again, I've got a 3. I could take this 1/5 and put it up here, or I could just put it out front, doesn't really matter. And then I've got 1 minus my variable term. This gives me then the following geometric series. I would have the sum from n equals 0 to infinity of 3/5 times negative 2x over 5 to the n. This function here can then be represented by this geometric series. Once again, only on the domain restriction for the geometric series, and not on the entire domain of the original function. Okay, last one. Well, this one is not a 1, and this one I've got x to the 3rd there, but it really doesn't matter. I just have to have my variable term in that spot. Let's go ahead then, and the only thing we have to do is, well, I need this to be a 1, so let's factor that out. This would give me 2 over 9 times the quantity, 1 minus 4x cubed over 9. And then I've got the sum, n equals 0 to infinity of 2/9. And then 4x cubed over 9 to the n. So we now see how to do a conversion from a series to a function, and then a function to a series. And this is a useful technique in numerous scenarios throughout your chapter when you learn about infinite series, power series, things like that. We'll get to some of those in other videos. But for now, that's all I got.